Hello and welcome back. So a lot of papers now are exploring the idea of training LLMs that themselves act as judges of other LLM outputs and make them think better before deciding. In a nutshell, LLM as a judge is just that. Turn the act of evaluation itself into an LLM generation task. Feed the judge a prompt X and two candidate answers A and B. Let it think out loud to compare them, and finally ask it to state which answer it prefers and why. While papers like RMR1 propose to solve this with a generative reasoning reward model, same as X, A, B, but the model first classifies the task as either reasoning or chat type task. Then if it's reasoning, it solves the task inside the solution tags and judges it. If it's chat, it self-writes a weighted rubric and judges via those criteria. And then there is this paper, JudgeLRM, which takes the score-first judge approach. In a sentence, model outputs a thinking trace and corresponding scores between 1 to 10 for the two answers. But now there's this new paper from Meta, which simplifies matters a little bit. Turns every judging task, whether it looks objective, for example a math question, or subjective, example a wild chat prompt, into a verifiable binary preference problem. This lets the author attach a clean reward signal and run online reinforcement learning with GRPO. The product, two open-weight models, J1 8B and J1 70B, which beat all previous 8B and 70B judge models on 5 popular reward model benchmarks. But benchmarks are not so important. So why is this any different and why does it matter? Well, let's first look at the methodology. J1 frames the problem statement by formalizing pairwise judging. Given a user instruction X and two candidate answers A, B, the judge produces a chain of thought T and a verdict Y which belongs to A and B. Why pairwise judging, you ask? Pairwise comparison is natural for RLHF data and it's easier to verify than pointwise scoring. First, let's talk data. They built 22K synthetic preference pairs, 17K of which comes from wild chat, which is subjective, and 5K of which comes from math, which is objective. For every triplet XAB, they also create their swapped order XBA. Swapped order helps to mitigate position bias. Now comes reward modeling, which is pretty neat. Two sparse verifiable rewards per training step. First, for verdict correctness. 1 if chosen answer matches ground truth, else 0. Second, for verdict consistency. 1 only if the judge answers both XAB and XBA correctly. Finally, the training recipe, which uses pairwise verdict. This uses the seed prompt in the paper, think and answer, optimized end-to-end with GRPO. It starts with Llama 3.1 8B instruct or Llama 3.3 70B instruct. GRPO removes the need for separate critic network, keeping RL stable with only 22K items. Now what the fudge does it all mean? Well, let's recap. First, for every user prompt X, the authors create a verified winner or loser pair. For math-style tasks, they pick the answer that reaches the gold solution, and for open-ended chat, they manufacture a worse answer by perturbing the prompt or sampling again. They then duplicate each pair with the order flipped, XBA for XAB, so that every mini batch always contains both orders. This makes it possible to spot and punish left versus right bias in the judge. Two judge models are trained side by side. Pairwise J1, which reads the two answers together and either emits a binary verdict or two scores, and pointwise J1, which scores each answer separately. After the judge writes his chain of thought, a tiny rule-based reward module gives +1 for a correct verdict, +1 extra if the verdict stays the same in the swapped order, and for the pointwise path, +1 if the winning answer got the highest score. These sparse integers then feed into the GRPO reinforcement learning loop, nudging the models to write more useful reasoning and to stay self-consistent without ever needing human levels. So what was the big deal? All this to create new Llama models? Is that it? Well, see, J1 shows that you can get state-of-the-art open-weight judge with far less data and a much simpler recipe than other papers, using only 22K fully verifiable synthetic preference pairs and a 2-number reward. It shows that tiny verified data and position-aware rewards are enough to surpass far heavier pipelines, yielding a general-purpose judge that is smaller, more transparent, and immediately useful in open-source RLHF loops. And that was it. Let me know if you would think of using J1 models in your pipeline. I will see you again next week. If you liked this video, you know what to do, and if you have feedback, you know where to share it. If you have suggestions, you know where to put them as well.